So thank you for attending this webinar, Jumpstart to Using Petrasys. My name is Andrew Weller and I'm a support and training geoscientist based out of our Perth office. The purpose of this webinar is to give you a half-hour overview of a few key features and functions of Petrasys to help you quickly get acquainted with its core workflows and operations and get you creating maps and grids in no time at all. I've put at the bottom there that this webinar is recorded. After the webinar, I'll edit and collate the video and I'll put it up on our YouTube channel and also our website. So if you miss any of the information, you have the ability to go back and watch the recording after the webinar. To summarize the key features of Petrasys, in our mapping module, I will directly display some 2D seismic navigation and wells, a Petrasys grid and contours that we will create, as well as some spatial and permit information. I will finish the webinar with a 3D visualization to help bring things together. I'll demonstrate our surface modeling and volumetrics module by creating a grid and contours from 2D seismic, as well as performing some grid arithmetic. Throughout the webinar, I'll showcase our Direct Connect technology, which is the ability to link to third-party data stores and display spatially aware data on your Petrasys maps. So without further ado, I'm going to jump into Petrasys. The first thing that I'm presented with here, let's just minimize some objects on my desktop. The first thing that I'm presented with here is the main Petrasys menu. The thing that I'm going to focus on now is the project selector. So the first thing I need to do before I launch Petrasys is select an appropriate project. I've got a list of projects here that I've already been working on, but for the purpose of this webinar, I'd like to create a new project. If I had some projects that already exist on my local machine or over the network, I can add those or copy those into my project list. So I'm going to go ahead and create a new project. Now at my site here, I've already got a project template. So I can select that project template which incorporates things like map sheets and other information that I just want to copy across to my new project. And I'm just going to call my project my new project for want of a better name. I also have the ability to change where that project is stored, whether that's locally or over the network. And I also can assign a group to that project. Once I've assigned a group, I can give groups certain privileges so that they have access to certain information. I can also define what the coordinate reference system or CRS of my project is. I'm going to leave this as the default and just click OK. So that's copied the data across and it's brought it through to my new project. You'll see at the bottom here I have the ability to see some of the information pertaining to this project, where it's located, what groups it's a member of, its CRS, coordinate reference system information, etc. And I'll just click OK. So I've now brought through my new project. Now that I'm in my project, I have the ability to launch Petrasys mapping, the 3D viewer, or surface modeling. I also have the ability to view and edit seismic data in a Petrasys SDF, well data in a Petrasys WDF, or GIS or spatial data in a Petrasys CUL or CUL file. I'm going to start off by launching mapping. So one of the first things you'll notice are the icons that are used in the mapping window, improving your access to those commonly used functions. And I've got my display data toolbar down here on the left, and it's where I'm going to focus most of my time. Before I can display any data, I need to make sure that I have a map sheet open And I'm just going to double click on the Targa regional map sheet and bring that through. Now, a map sheet is a template which defines or shows your area of interest with a particular style and scale. The map sheet is fully customizable in terms of scale, annotation, and its associated coordinate reference system. Now, a fundamental feature of Petrosys is the ability to display data on your map in a wealth of CRSs, as CRS transformation is performed on the fly to the CRS of the map sheet. So the CRS of your map sheet is the ultimate CRS. A customizable title block containing specific company information is also available to place on the map sheet. So now that I've got my map sheet or the bounding box where I'd like to display some data, the first thing that we may wish to display is some 2D seismic. So I'm going to click the Display 2D Seismic icon. Now from here I can specify where I would like that 2D seismic to come from. I can connect to my OpenWorks project, Petrel, Sizeware projects, and pull through that 2D seismic and use it in my map sheet. I'm going to specify S&T Kingdom. I'm going to connect to my Kingdom project and make sure that the CRS of my project is set accordingly so that when I display this data it knows where it is in space, and click OK. I'm going to leave my line style as is and display the line name. I'm also going to tick on Display Interpretation Data and pick a horizon that exists in my S&T Kingdom project. I also have the ability to display seismic data. Now if I come to the Ribbon Map tab, seismic horizon data can be displayed directly from third-party packages, so in this case our Kingdom project, and we can use a number of visualization techniques to display that data. So I'm just going to tick on River Map and click OK to accept the defaults. And you'll see that I'm displaying my 2D seismic with interpretation directly from Kingdom. Now my maps in Petrosys are fully interactive. If I click on a 2D seismic line I can drag through and you'll see the bottom information bar gives me some information pertaining to that seismic line. You can directly display faults from your third-party interpretation projects, which includes support for displaying faults from Sizeware. And this is where I would specify my fault data source. I'm going to display from the same Kingdom project, and I'm going to select this horizon and click OK. And I display my faults from S&T Kingdom. I want to display some spatial or cultural GIS data on this map. So I click on the GIS icon. From the drop-down, I can specify spatial data from Oracle Spatial, from Petrel, from Petrosys file types, a map info file. In this instance, I'm going to select the shapefile, and the shapefile I'm going to select is my Targa block boundaries. I'm just going to go to the Shape tab and change the line style associated with this shapefile. Let's make it a little thicker as well, and click OK. I can also annotate, filter, and thematically map spatial data. And I click OK to display my block boundaries from a shapefile. I may now wish to display some well data on my map. Again, from the data source drop-down, I can display wells directly from Geoframe, OpenWorks, Petrel, etc. I'm going to specify our S&T Kingdom project. Under the Well Symbology tab, I can display symbols for the surface, the bottom hole for a particular zone or formation. If I specify current, What that does is pull the symbology down from my Kingdom project and display that correct symbology in Petrasys. I can annotate my wells. I'm going to annotate at the bottom hole. I'm going to tick on an SQL query, and I'm going to query my Kingdom data to display the well name at the bottom of the hole. I'm just going to change the color and change the size of my annotation. I can display well paths down the entire well, or I can choose to display a particular path segment between formations in Petrasys. I also have the ability to display formation top information, and I can display formation or interval isopachs, but I won't use those in this instance, and just click OK. And I've brought through some well data. At this stage I can use my mouse wheel to zoom into my map. I can hold down my mouse wheel and I can pan around my map. So I've got mouse shortcuts that I can use to view that information that's pertinent to me. I also have the ability to tidy up the annotation using overpost correct in Petrasys. Let's move that window down here. And that gives me the ability to pull my text apart and put it exactly where I want it to be on my map. So I can really produce a nice, tidy, professional quality looking map here. I click OK, and that movement, that overpost correcting, has saved itself on my map. When I save my map, that correction that I've made is honored, so that when I reopen my map, all those movements will still be in place. Now it's a good point now to tell you about Petrasys maps. The maps that you save in Petrasys are dynamic. I've made several connections now to my S&T Kingdom project. If I were to save this map, then close down Petrasys, do some interpretation in Kingdom, and reopen this map perhaps in 6 months' time, the changes that I've made in my interpretation project will come through on my map, or my map will represent that new interpreted or raw data. But of course we still have the ability to save static maps in Petrasys, and I'll show you that later. We can query data from the map. If I right click on this well, I can view information relating to the formation tops. And you'll see I've got some top depth here for particular formations. As I click on different wells, you'll see that that live information is changing. So I'm just going to close that. I'm going to go back to my full extents. I'm just going to tick off my wells. I'm going to modify my seismic layer just to tick off the ribbon map. And I'm going to save this map out, and I'm just going to call this my map. The extension DBM is appended automatically, and just click Save. And we'll come back to that map later. So at this point we may wish to produce a grid and some contours from your data. So I'm going to jump back to the main Petrasys menu and launch Surface Modeling. So again, you'll notice there's icons along the top which will help improve your access to those commonly used functions. Now to create a grid, I'll go Grid, Create Grid. The output grid name, I'm just going to leave this as Top Valanginian. I can specify the output CRS. At this point, I can click on the output CRS and pick any CRS that's contained within the EPSG database to use. But I'm just going to leave my default project-specific CRS. Now that I've defined those outputs, I specify some input data. Most common data types can be used as input to gridding, including well data, seismic interpretation, spatial data, point data, contours, etc. Multiple data types can be combined from multiple data stores in multiple CRSs to produce a single output grid in Petrosys. I've already got some data there. I'm just going to remove that from this list. And I want to add some seismic data. Again, from the data source, I can pull data down from SeisWorks, from Petrel, from Sizeware, but I'm going to specify SMT Kingdom. I'm going to connect to our Kingdom project, making sure that my CRS, my coordinate reference system, is accurate. The horizon is my Valanginian Merta. My data type is time, and I'm going to use the 2D data that resides in that project. I click OK. Now at this point we can see I've got one layer or one data source to grid. If I wanted to, I could add several seismic data sources from several different projects that reside perhaps in Petrel or SMT Kingdom or Geoframe, etc. And I'll click OK. After I've specified the input data, I want to specify the geometry or the area of interest over which I want to create my grid. I'm going to leave this as the map sheet, and I'm going to make sure I select our Targa regional map sheet, which is the one that we've been displaying data on. At this point, I can input my cell size in X and Y, so we can have square or rectangular cells in Petrosys. I can also specify a rotation angle, so instead of banging out a cell size in north-south, I can slightly rotate that if I want to. Under the Methods tab, Petrosys supports algorithms such as Kriging, Bias Grid, and the others that you see here. I'm going to leave this as standard gridding minimum curvature. I can incorporate faults in the gridding process. So again, I'm going to connect to my SMT Kingdom project and pull through the faults for the Valanginian Merta horizon. I can clip my output grid. If perhaps I have a filled polygon, I can use that now. I can smooth my grid to get rid of those relative highs and lows or those outliers that appear in my data. I have a reporting window which will give me a graphic display of the grid that's produced, which will allow me to spot errors very quickly in the gridding process. And my final tab here is contouring, and I'd like to produce contours. You'll notice that the output file name is the same as my grid, just that the suffix CON for contours has been added. My contour increment, I'm going to put in as 10. And now the contour increment specified here determines the minimum contour increment that can be displayed on the map. This is fully editable, and contours at specific increments can also be added. Contouring can be performed as a specific task without the need to recreate your grids from scratch. So after I've input that data, I'm going to click OK. I'm just going to overwrite these grids because these already exist in my project. I click OK. And I now have one task in my workflow. This bottom part of the window here just gives me a verbose reporting output as to the calculation that's been performed. I'm just going to minimize surface modeling and just jump back to my map. If I go to Windows Explorer and just navigate to my project, a nice shortcut I can show you here. I just navigate to the grid file that we've just created. I can grab that from my project, drag and drop it onto my Petrosys map. So Petrosys allows you to fully control the appearance of your surface. Any surface you display can be clipped at a minimum or maximum value. Petrosys can display surfaces with a variety of built-in color fill gradients, or you can create your own. The translucency of any displayed surface can be adjusted, enabling the generation of sophisticated multi-layer maps. So I'm just going to jump back into surface modeling. So we've got our one create grid task here. I can copy and paste that task. I'm just going to cancel there because I don't actually want to run it. And just double click that task to modify it. I'm going to change the output name to Top Hutton. I'm going to leave my CRS as is. I want to alter the input data. And I'm just going to change the horizon from my SMT Kingdom project and click OK. I'm going to turn off faults because I don't have a reliable fault set for this horizon, and I'm going to tick off contouring and click OK. You'll now see that I'm building up my workflow or my task list. I've got 1, create grid for a particular horizon, 2, create grid for another horizon. At this stage, I might like to perform some grid arithmetic. So I go grid processes arithmetic. I'm going to clear what's in the formula field and use one of our templates. I can do some simple arithmetic here. I can add grids together, subtract grids, and so on and so forth. I also have some grid operations if I want to clip grid to a minimum, merge grids to a maximum, or replace missing values that reside in a grid. It's at this stage that I would launch some of our depth conversion algorithms. But I'm going to jump to Geoscience Examples and compute the isochron. I click the drop down to populate my variables. I need to give my output grid a sensible name. In this case, I'll just call it isochron as my output. I then need to specify what my top and base grids are. So my base grid is my top Valanginian, and my top grid is my top Hutton. I can then define an output geometry, use faults in that process, clip the final grid, smooth and contouring, just as I can when I'm creating a grid in Petrosys. And I click OK. Once I have my workflow here, I can click Run All Tasks. Yes, I want to overwrite those grids, and away it goes and computes those grids and does the arithmetic. If I wanted to perform well tie, I do well tie from within surface modeling, where I have my input surface and tying it back to a particular point data source. It's within surface modeling that I also perform volumetrics, and I can perform volumetrics using a top grid, a top and base grid, or I can have a thickness grid. So I'm just going to minimize my surface modeling and come back to my mapping. Now the grid that I've dragged and dropped onto my map is at the top of everything. If I go to my display list here, it shows me all the layers or objects that I've got displayed on my map. I can grab my grid and just drag that to the bottom, and it puts it beneath everything. I can change the way that these objects or layers are grouped. I can view the grouping by CRS or coordinate reference system, by data source, so I can see all those objects that I'm displaying from my SMT Kingdom project, by layer type, whether things are seismic, grids, worlds, etc., or by the display order. If I want to create my own group, I can create my own group here too, and I can bulk tick things on and tick things off when I've got my group. We also computed some contours. So let's navigate to my top Valanginian contour and display at the increments that were computed. So I'll put in increments at 10 and at 50. I'm just going to change the style here for the 50th and just label those as well. Let's just change the size, make that a 5, and click OK. And I display my contours from the gridding process in surface modeling. I can zoom in, of course, using my mouse wheel, and you'll see that I've got labeling parallel to my contours. I can also click on a contour, and you'll see that it gives me the area of that contour, of that closed contour. If I just go back to the full extent of my map, I may want to create a new map sheet here. So I can go map sheet new, pick on map, easting northing. I give my map sheet a sensible name. Let's just call this prospect area and click OK, and it gives me some crosshairs so I can drag and cookie cut an area out of this map. I want to give it a sensible title. Let's call it prospect area. I will change the scale to 10,000 and just check the sheet size here to make sure that it's sensible for my plotter, and click OK. Yes, I want to retain those overpost corrections that I made for the well data, and it's quickly and easily created that map sheet. So I've got a new map sheet, but you'll see that the objects or the layers that are displayed stay the same. So that's important in Petrosys, that my display list and my map sheets are independent and interchangeable. I may have missed an area off my prospect area here. I can quickly grab that by going map sheet edit. I can resize my map sheet and just pull that out in these two directions. I click OK and OK, and very quickly and very easily it's resized my map sheet, but everything is still spatially aware. Petrosys still knows where everything is in space on that map. Once I've got that, I may wish to use the print icon just to print to a printer or plotter. But I can also export a static map. So I'm just going to export a PDF here. I save that on my desktop. Just navigate back to Windows Explorer, go to my desktop. I've got the PDF that we've just created here, and I'll open that. And you'll see how quickly and easily I've created that static PDF of my map. So I'll just close that. I'm going to jump back to my main menu and just jump into the 3D viewer just to finish off here. So the Petrosys 3D viewer has a similar interface to 2D mapping. The 3D viewer complements 2D mapping. It allows you to QC your surfaces and grids and display wells and other spatially aware data. So I'm just going to display a grid. I'm going to select my depth grid for the top Valanginian. Just make sure that my Z-value scaling is correct. I click OK, and my grid has come through. I can use my mouse. Just hold down the left mouse button and I can rotate around that view. I can also display wells, and I can again connect to a third-party data store here. I'm going to leave it as SMT Kingdom and connect to the same Kingdom project that we've been connecting to throughout the demo. I'm going to leave the symbols as they are. I can display well header information. I can display well paths, and I'm going to display well paths that are slightly thicker so that we can see those. I can also display formation tops, and I'm going to leave formation tops and put a size in at 100 and click OK. And you'll see that my well data comes through with those formation tops If I can rotate this and use my mouse wheel to zoom in, I can jump to pick mode and I can select that formation top, and you'll see I get information pertaining to that top in the information bar again. So this is essentially a live feed directly from my Kingdom project. I just go back to the default view, and I can also display a Petrosys map file in my 3D viewer. So I can pull through the My Map that we created earlier and click OK, and you'll see, hopefully, that that has come through as a plane, and I can drag that through. Let me just try to zoom in here so that we can see that data better. So you'll see I've got that spatial data, my block boundaries, my 2D navigation data come through from the map into my 3D viewer. I can modify that display. Let's just change that. And I can drape that surface over, that map over a surface that resides in the 3D viewer. Let's just click OK and close that. So you'll now see that that spatial data is draped over that surface. If I go back to my default view, I can add viewpoints. I can rotate around, add a viewpoint. I can seek to areas or structures of interest in my 3D view and add a viewpoint. I can rotate around, add a viewpoint, seek to particular wells and structures and add a viewpoint. So we can zoom to particular areas, we can add viewpoints, and we can ultimately animate that selection and save this out as a movie. So I'm just going to put the duration here at 8 seconds and click play, and you'll see that it interpolates between those viewpoints, and I've created that movie. As I said, if I want to, I can save that movie out as an MPEG, and I can embed that into presentations. So I'm just going to stop. Let's just close, minimize my 3D view, and just jump back to my PowerPoint. So in the demo, you've had the opportunity to see Petrosys mapping. We've had a look at some surface modeling. We've created some surface and the 3D viewer. And we've also done some direct connects. We've connected to our Kingdom project and used that data in surface modeling, displaying that data in the 3D viewer and on our 2D maps. As well as Kingdom, we also support other third-party data stores, Paradigm EPOS 4, Petrel, Landmark products, as well as our own dbMap. So thank you very much for your time. Thank you for your attention.